Hey guys, welcome back. Today is Thursday, April 23rd, and we are moving on to lesson 11-2. Today we are actually going to make line plots. It is going to be so much fun. We're going to start with the solve and share on Math Workbook, page 597. So please take out your Math Workbook, have it open to this page, and let's get started. All right, so it says, in a class of 27 students, 5 students have one pet, 3 students have 2 pets, 4 students have 3 pets, 2 students have 4 pets, 1 student has 8 pets, holy moly, and the remaining 12 students do not have any pets. Are there any outliers in this set of data? Explain. Now, it says we can do anything we want to solve this problem, but I know that outliers are data sets that are a little bit not normal, right? They're a little bit further away from the other data points. So I think a line plot would actually be a great way to show this data and to see if I have any outliers. So I am going to make a number line. And I want to kind of make it low. I don't want to make it too high because I need room to make my little dots or my X's. All right, so let's see. 0 pets is like the least amount, right? And then there's some people with 1 pet, some people with 2 pets, 3 pets. Let's just keep going. 4 pets, 5 pets, 6 pets, 7 pets, 8 pets. Oh, I can fit one more, so I'll do 9 there, right? Oh, I'm sorry. Couldn't even see that. All right, now it's time to plot my data points. So I'm going to let's do red here. All right, now I can do dots or I can do X's, whatever I prefer. So it says 5 students have 1 pet. All right, so I'll do dots. Let's see, 5 of them. So 1, 2, 3, 4, 5. All right. 3 students have 2 pets. So 3, 1, 2, 3. 4 students have 3 pets. Right, 1, 2, 3, 4. 2 students have 4 pets. I'll make 2 dots there. 1 student has 8 pets. Wow, you must live in a zoo. And let's see, the remaining 12 students do not have pets. So that would mean they would have 0. So I need to make 12 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whew. All right. So, what was my question again? Are there any outliers in this set of data? And yeah, it's pretty obvious that we have an outlier here, right? This kid right here that has 8 pets, that guy is our outlier. Why? Because he is drastically different from all of the other kids in the class, right? And what is the most common number of pets? If they were to ask that, well, that'd be 0, right? Most people don't have any pets. And we could say, what is the difference between the most number of pets owned and the least number? So 8 minus 0 would be 8. What else could we ask? What are the total number of pets? So we'd have to add 8 plus another 8 plus another 12 plus another 6, right? And adding all of these dots up would give us how many kids there were, which we already know that's 27. So lots of different questions can be generated using line plots. Down below it says, how can you use a line plot to find the data that occur most often? And we actually already did that when we were showing our 0 group, right? The kids with no pets. The highest column of dots or X's shows the data that occurs most often. And so here in this plot, line plot, it would be those kids that owned no pets at all. All right, let's keep going. If you follow along on the next page, it's page 598. But instead of actually using the page in the workbook, I'm going to show you a video. So you can follow along with your page as we watch the video.
How can you make line plots? Think about this question during the lesson. Serena measured the lengths of her colored pencils. How can Serena make a line plot to show these lengths? Why might Serena want to organize and display the data in a line plot instead of a table? Serena can look for patterns. She could see which lengths of pencils occur most often or least often. What is the length of the shortest colored pencil? 4 1/8 inches. What is the length of the longest colored pencil?
Okay,
select your answer.
All right, so let's take a look. They want to know the longest, and it looks like the longest would be the 5 inches, right? That red.
The longest colored pencil is 5 inches. How does knowing the lengths of the longest and the shortest colored pencils help you draw a line plot?
Well, knowing the shortest and the longest can tell you your end points, right? Where to begin and where to end your line plot. Let's see if we got that right.
It tells you where to start and end your number line. Now make a line plot.
Ooh, okay.
Step 1. Draw a number line and choose a scale based on the lengths of Serena's pencils. Mark halves, fourths, and eighths.
You can use equivalent fractions such as 1/2 equals 2/4 equals 4/8 to help make a line plot.
Thanks, Carlos.
The scale should show data values from the least to the greatest. Step 2. Write a title for the line plot. Label the line plot to tell what the numbers represent. Step 3. Draw a dot for each pencil length. Why are there 3 dots above 4 3/4?
Okay, well, why are there? Because there are 3 pencils that are that same exact length. Let's see what they want me to do here. Try it. Select a row in the table to identify the data in the line plot. All right. In the data.
1 pencil is 5 inches long.
Okay, and you see how it's red there. Let's do the blue.
3 pencils are 4 3/4 inches long.
Yeah, that's true.
1 pencil is 4 1/8 inches long. 1 pencil is 4 1/2 inches long. 3 pencils are 4 3/4 inches long.
All right.
There are 3 pencils that are each 4 3/4 inches long. Now you know how to make a line plot.
Awesome. All right, we're going to go back now to our workbook page. And now we do know how to make a line plot. All right, we're going to go right now to the next page in our workbook. And we are going to talk about the line plot up on page 599. Page 599. Okay, so we are going to take a look. We have, these are the lengths of Sandy's pencils. And then here is her line plot. So they want us to actually plot the lengths of her pencils. So let's do that. I'm going to use a thin marker though, because I feel like I want to make sure that there's not much room up here. Okay, so first thing I want to do is just take a look. I have, let's see, 6 1/4. I only see one of those, right? I have 5 1/4. It's only one of those two. 6 3/4. Oh, there's 2 of those, right? So 6 3/4, 6 3/4, 6 2/4, and then 5 3/4. Okay. So there's one at 6 1/4. So I'm going to put a little dot there and cross that one off so I don't do it again. Blue is 5 1/4. There's one of those. Green is 6 3/4. 6 3/4. 5 3/4. That would be there. 6 3/4. Do another one there. And 6 2/4. All right. So those are the lengths of Sandy's pencils. And I just simply use that data table to compare it. And there is a question over here. It says, like, is there an outlier of data for Sandy's pencils? And honestly, I would say no, because there's none that are like drastically different from the others, right? So this answer right here would be no. All right, let's move down to the independent practice. So we're going to use this table or this data to the right. It's all talking about lengths of bracelets. And you're going to see these are mixed numbers in here using fractions. And we are going to plot the lengths or how many the lengths of in inches. So let's take a look at that. We have one bracelet that is 8 inches here. So let's plot that one. And then I like to cross that off. 6.5 inches. All right, we got one there. 7.5. All right, that would be there. 8, another 8. Okay. 6.5, another 6.5. It's good to try to make your dots about the same size too. Another 8.5. Oh no, this was my first 8.5. 8. 6.5. Oh, there's a tie so far. 7.5. And 8. Oh, we have a winner. Okay. So my question is, what is the length of the longest bracelet and what is the shortest length? All right, so the longest bracelet, see how it's just easier to look up here than it is to like sort through all of these data points in the table. So the longest I would say is 8.5 inches equals the longest. And then the shortest, you just look back over here, would be a 6.5-er. So 6.5 inches would be the shortest. Voila. All right. See how it makes it just so much easier to look at that line plot than to kind of look at that messy data table. All right, flipping over, we have, actually, you know what? I'm going to skip this page with you guys. And I highly suggest that you go back to it if you're having trouble with line plots or want a little more extra practice, and do this page. But we're going to skip right to the homework page. Let's see if I can find that. All right, it's the one with a big hand on it, right? There it is. All right, so up at top of the homework page, page 601, they're giving us like a little recap about how to make a line plot. And so I just want to quickly go over the steps because you're going to get to make your own line plot tomorrow. It's going to be so exciting. And we're going to show it off on Flipgrid. It's going to be super fun. So you're going to have to know how to follow these steps. So Dorothy measured the lengths of the fingers on her hand. All right, you could do that for your line plot if you really wanted to. She measured the length of her thumb. She got 2 inches, and then she did that finger. It was 2.5 inches. And then she wanted to put it in a line plot to show her measurements. So step 1, she draws a number line and chooses a scale, right? Like her starting point, her ending point. And her scale is going to depend on like her longest length finger and the shortest length finger, right? So she decides to start at 2 inches and she goes all the way up to 2 3/4 of an inch. The second thing that she decided to do was write a title for the line plot and a label for the numbers down below. So her title was Lengths of Dorothy's Fingers. How exciting. And her label was inches because she wanted us to know that these numbers actually represent inches, like a measurement. And then finally, her last step was to draw a dot for each length. So she did that. I guess 2 of her fingers were 2 inches. Oh yeah, look, her thumb and her pinky. And then one of them was each of these other lengths. All right, and bam, she is done with her line plot. pretty easy. So, I mean, a line plot does not have to be complicated. All right, let's do one more practice before we end this video. Let's talk about Aiden. Aiden, I guess, has some more little toy cars that he likes to play with, and he measures them. So it says Aiden has 2 toy cars that measure 2¼ inches. So let's see, if we were going to plot that, 2¼ would be right here. And he has 2 of them. Okay. So I can kind of cross that out so I don't reread it. He has 3 that measure 2�3/8. So 2�3/8 is here, and he has 3 toy cars. So I'm going to make 3 dots. 1 that measures 2�7/8. I'm sorry, I crossed out the wrong thing. 1 that measures 2�7/8 inches. 1 that measures 2⅛. That would be there. And 1 that measures 2�3/4. So 2�3/4. Okay. Use this data to complete the line plot at the right. So there is Aiden's car lengths. How long is Aiden's longest toy car? I'd look all the way to the right. I'd say 2�7/8 inches is his longest one. Which length appears most often on the line plot? Well, if I look, the one that has the most dots going up is 2�3/8. And final question, are more cars shorter or longer than 2½? So let's find 2½, that'd be here. Are there more that are shorter or longer? Well, there's only 2 that are longer than 2½. So the answer would be shorter. Right? There's more that are shorter. There's 1, 2, 3, 4, 5, 6 of them that are shorter, and only 2 of them that are longer. All right, and that about sums it up for today's learning. I do highly encourage you, if you want a little more extra practice, go on to the back of this workbook page. Also, the back of page, 600. Those would be excellent pages to complete if you're looking for just a little bit more practice on this skill. Have a great day, everyone.